when you talk about AC circuits, one of the things that I found students didn't really get was this. V as a function of t is some maximum amount sine omega t. That's how we represent an AC voltage source. And you can draw it and stuff like that. But I want to show this whole omega t, what does that even mean? And I thought it'd be fun to kind of like do it visually with Python. So I want to graph this. I want to make a rotating vector in Python and kind of use it to plot this. Kind of. It'd be fun. Okay, let's do it. Switching over to Python. Here we are. I'm using WebVPython. I think WebVPython is great for a couple of reasons. Number one, it's online. Number two, you don't have to load anything. It's already got all the visual stuff in there. And it can be used as a great visualization tool for students, and the code's still simple. So let's just start. If you're not familiar with this, that's fine. So I need some constant. So I'm going to have a 3-volt voltage source. I'm going to have an angular frequency of 1. I'm just picking some numbers here. And then I am going to have time as a variable, because that's that time in the omega t, and then need a time step. Because what I'm going to do is like calculate the voltage at each time and plot it. But I'm going to draw it as a vector. And I'm going to make that vector rotate. So the first thing I want to do is to I kind of want to make an X and a Y axis, and this is in 3D space. So let's use the arrow object in Python. And I'm not even going to give it a name because I'm not going to change it, I'm not going to move it, I'm just going to draw it. So an arrow has two main properties. It has the position, which is the location of one end, and then the axis is a vector from that one end to the other end. So I'm going to say that it's at the origin. Position is vector 0, 0, 0. And the axis, I want it to be a little bit longer than the v vector, so I'm going to make it 4. Axis is vector 4, 0, 0. And if I just run this, let's just see what it looks like. And there's my arrow. See, that's pretty easy. It's in 3D. That's kind of cool. Now, I do want it to kind of like look like an axis, so I'm going to make it like skinnier. You can do that with a property called shaft width. Shaft width equals 0.303, I think is what I tried. Now, that looks pretty good. Now I need to make one in the negative x direction, the positive y, the negative y. So let's just copy this and paste it. The old copy-paste trick. And just put the axis in the negative direction. So now I have like a double-ended, see? Isn't that nice? Now I'm going to copy that again. And I want to put this in the y-axis. So 4. And then I'm going to do that one. And then make a negative. And then, boom, I got my x and y axis. See? And look, it's in 3D. Isn't that cool? Okay, so now what I want to do is to make my voltage arrow. And I'm going to rotate it. So this one, since I'm going to change the axis of it with time, I'm going to need to make it a named object. So let's call this VP for the phasor. That's one of the things, capital V. And it's going to be an arrow. That's an object type. Its position is going to be at the origin, so vector 0, 0, 0. And then its axis is going to be V0 times vector cosine omega times t sine omega times t 0. And you don't actually need, we only want the y component. That is what we're going to plot. But I'm going to show the whole thing so you can see that component. And let's make it yellow, because I want to make it yellow. Color equals color dot yellow. And I think, let's see, I think I should give it a shaft width of 0.2. Because otherwise the default shaft width changes. And so I don't want it to change. So I'm just going to, if I put shaft width equals 0.2. Let's just run that. It won't move. There. So it looks pretty nice. Okay, now we're going to move it. So let's go and make a loop. I'm going to say right here, I'm down here. While t less than 5, rate 100. So how fast you want it to rotate is the rate, right? Because this is don't do more than 100 calculations per second, 100 loops per second. And if I have a time step of 1, oops, that should be 0.01, then it'll be in real time. So it's not real anyway. So all I need to do is to change the axis of that vector. So vp.axis, I don't need to move it, is v0 times vector. It's the same thing. It's the same thing, right? But now t's changing. And I'm going to need to change t or I'm going to be in big trouble. And then I'm going to update t equals t plus dt. And then that should do it. Let's see what it looks like. And so there's my rotating voltage vector. Now I'm going to make another vector that's the projection of that vector onto the y-axis, which would be the magnitude of the v0 sine omega t, right? Because that's the y component. So let's make this other arrow. I'm going to call it just v. V is an arrow. Let's copy this. Let's just copy that whole thing. I'm going to call it v, and it's going to be an arrow, same thing. Now, its axis is only going to be in the y direction. So I'm going to delete this 0, 0 cosine. And I'm going to make it a different color. Let's make it cyan. Now, down here, I need to change the axis of that. So v dot axis, well, I think so. V dot axis is going to be equal to v0 times vector 0 sine omega times t 0. So it only has the y component. That's nice. Look at that. And so the cyan vector shows us the changing voltage. That's our changing voltage. We can represent that with this rotating vector. It's kind of fun. But wait, there's more. Let's make this into a fake 3D graph. So I want to have a ball that kind of moves horizontally with a constant time, constant velocity, and then moves up and down with respect to that thing, just so it'll look cool. It'll look cool. It's gonna be cool. Okay, so I need to make a new object. I'm gonna make a ball. I'm call it B, and it's a sphere. Its position is gonna be at the origin. Start at the origin. And oops, yeah. And its radius is 0.1. And then let's do make trail equals true. So it'll leave behind a trail. No, not true. Stop it. There. Okay. Now I also need a velocity. So let's just say 0.5. That's going to 5 volt-meters per second, right? Because I'm displaying the voltage as a distance. So those arrows have length. And so I have to have a velocity too. So, and let's just move that ball. So b.pos is going to be the vector. In the x direction, it's just going to be v times t, right? Because it's just going to be the velocity times time. It's going to keep moving. So v times t. And then the y direction is going to be v0 times sine omega times t. And then the z direction is 0. I think that should work. And so you'll notice it's right there along with the same. It looks like it's higher, but I don't think it actually is. Huh. I think it's okay. Yeah, and now you see this sine graph. It's actually a 3-dimensional thing. Oh, I ran for 5 seconds. Let's increase this angular velocity to 2. It'll go twice as fast. That's a little bit better. Yeah, I think it's the same. It just looks that way. I might need to increase the velocity, but you see that we have this pretty nice. Now, I do want to do one more thing. I'm going to add a line from the top of the cyan vector to the ball. So let's make another object called, what should I call it? Stick. And it's an object it's a cylinder. And so I need to start with it somewhere. Everything starts at 0, so it's fine. So let's just say the position is, let's just put right now, vector v0. It's going to move up and down with that arrow. So it's v0 times sine omega times t. In the y direction, the x direction will be 0. And then 0. And that's the position And then a cylinder, just like an arrow, it needs an axis. So axis is going to be, let's start this as 0, 0, 0. That's where it's going to start. And then I need a radius of, let's say, 0.01. Let's just try that. Okay, so that's my axis. Now I need down here, I need to move that. So I'm going to need to move the position. So stick.pos equals, it's going to be the same thing, but that's going to move. And then stick.axis is going to be equal to the x position of the ball. So that's going to be equal to vector v times t 0, 0. I think that should work. And let's make this velocity a little bit faster. 1. And I made a mistake. Axis must be a vector. Okay, where did I make an axis not a vector? That's a vector. That's a vector. Well, I added this cylinder, position, axis equals, oh, I didn't type vector. That's how you know this stuff's real. Okay, there it is. I want to stop. Radius, let's make that a little bit thicker. Yeah. That's pretty cool. I don't know what else to say. I'm just pretty happy. It's going to watch it. You know, it's kind of like this artistic thing. You know, this is really, I think, powerful in Web VPython to make this stuff pretty quickly. We can show this to students. They could even make it themselves. They could look at the code. They could understand it. There's nothing like super complicated that you couldn't understand, and that's what I like about it. The end.